approach for mortality prediction for heart patients using ACO HKNN. So now coming to the introduction part. Within the healthcare domain, accurately predicting mortality among heart patients poses a crucial challenge, calling for inventive solutions. A potential and innovative research direction involves crafting a hybrid methodology that merges ant colony optimization, which stands for ACO, and HKNN, which stands for hybrid k-nearest neighbors algorithms. This method aims to leverage the collaborative intelligence inspired by an ant behavior in ACO and the adaptable nature of HKNN to construct a resilient predictive model for mortality in individuals with heart conditions. So now coming to the objective part for this project is to improve the precision and effectiveness of predictive models within cardiovascular healthcare. The ultimate objective is to furnish healthcare professionals with a reliable tool capable of systematically and accurately forecasting the risk of mortality among individuals with heart conditions. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and cpon for visualization are important. So second, here we have exploring the data set. In this step, the data set is loaded and explored to understand its structure, checking for the missing values and gaining insights into the data. Third, here we have data processing. Using Pandas data frame, utilizing Pandas for manipulation and organizing the data, using ant colony optimization algorithm, applying the ant colony optimization algorithm as part of the data processing, possibly for optimizing certain aspects of the data set. The next here we have visualization using cpon and matplotlib. Visualizations are created based on different columns of the dataset using cpon and matplotlib. This step helps in better understanding the distribution and relationships within the data. The next here we have label processing. Label processing involves converting categorical labels from object type to integer type using techniques like label encoding. The next here we have feature selection. Features for the model are selected and the data is structured by appending it to xtrain and ytrain, where xtrain represents features and ytrain represents labels. Then next here we have data splitting to train and test. The data set is divided into training and testing sets to evaluate the model's performance on unseen data. Then we have building the model. SVC, which stands for support vector classifier, creating a model using support vector classifier. Decision tree, constructing a model using a decision tree algorithm. C4.5, implementing a model using the C4.5 algorithm. Then we have random forest, building a model using the random forest algorithm. Similarly for the naive Bayes, constructing a model using the naive Bayes algorithm. KNN, which stands for k-nearest neighbors, creating a model using the KNN algorithm. Then next here we have voting classifier, boosting plus RF plus C4.5, combining different models using a voting classifier. Then we have modified KNN with ACO, developing a KNN model modified with the ant colony optimization algorithm. And the next here we have training and building the model. The models are trained using the training data to adjust their parameters for accurate prediction. Then next here we have Flask framework with SQLite for sign up and sign in. Setting up a web application using Flask and incorporating SQLite for user sign up and sign in functionality. The next here we have importing the packages. Similar to the initial step, this likely refers to importing necessary packages for the Flask application. And the next here we have user gives input. User input data for predictions into the application. Then we have the given input is pre-processed for prediction. Pre-processing the user input to align it with the format expected by the trained machine learning models. Next here we have trained model is used for prediction. The pre-processed input is fed into the trained model for prediction. And the last one here we have final outcome is displayed through front end. The model's prediction are communicated to the user through the front end of the web application, providing the final outcome of the prediction. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then next here we have the folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. Next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. And the last one here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and the space path over here. Now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here. Now hit the enter button. So here you can see that this is our home page for the hybrid approach for mortality prediction for heart patients using ACO HKNN. Here you can see that there is a button for sign up. Just click on this button and this is a registration form. So just enter your username, your name, your email ID, your phone number and your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. So now just enter the username and the password over here which you have created while doing registration and simply click on login button. Click on OK and here you can see that there is a form where you have to enter the parameters. Like for age you have to enter the age, for gender you have to choose the gender, chest pain type as ASY, resting BP as 4, cholesterol as 5, fasting BS as 21, for ECG normal, maximum heart rate 4, exercise angina no, old peak 4, ST slope flat. So here you can see that there is a button for predict. Just click on this button. Here you can see the results. The outcome is showing as the patient is diagnosed with heart disease based on the machine learning. So depending upon the parameters we are providing over there, it will detect about the diagnosis with whether the patient is diagnosed with the heart disease or no. So here you can see that there is a button for about. Just click on this button and here you can see that there are many different graphs where we have used many different algorithms and based upon those algorithms we get the accuracy of those graphs. Here you can see that there is a button for sign out. Just click on this button and you can successfully log out with this. So now coming back to the conclusion part. In summary, the progress and implementation of a hybrid strategy for predicting mortality in heart patients which combines ant colony optimization ACO and HKNN, which stands for hybrid care nearest neighbors, mark a substantial advancement in enhancing precision within cardiovascular healthcare. This inventive approach, fueled by the cooperative integration of intelligent optimization and adaptable pattern recognition, offer the potential to improve the accuracy and effectiveness of mortality predictions for individuals with heart conditions. So here we have completed with that project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.